So now I want to discuss further about number 3 when I have already presented you the answer, but let's just discuss that X, let me remind you, is the number of old members who work. So Y is the number of new members who work, and D is number of dollars earned. So let's go to the restriction. How could we figure out the restriction? First, the number of old member, so X, is non-negative. It means it cannot be negative, but it can be 0, it can be positive. So this is the statement. And then the next one is the number of new members also non-negative. So this too is the translation of the first restriction. The second one, the club has at most 9 old members. Old members, X. At most, it means at most 9 can be accepted, less than 9 can be accepted, but not more than 9. At most 9 old members. And at most 8 new members. So Y, new members, is less than equals to 8. The next one, the department will hire at least 6 students, but no more than 15 students. So the whole students, either it is old member or new members, the department will hire at least. So it at least means the minimum. So 6 will be the least border. So it can be 6, it can be 7, it can be 8, but it cannot be 5. And then but no more than 15. So the whole students, both old members and new members, cannot be more than 15. So it is less than equals to 15. So before we go further, let me show you that actually I can combine the first restrictions and the second into this statement. 0 less than equals to X less than equals to 9. And also with the Y perspective, since Y is greater than equals to 0 and Y is less than equals to 8, I can combine it into this. So usually the statement can be translated into this, but I prefer you separate to make it easier for you to graph. So just separate it, rather than this form. So it's the same with this. The third restriction, actually we can combine these two into this long statement, but only one statement. So 6 is less than equals to X plus Y, while X plus Y is less than equals to 15. So it's the same. But again, I will remind you that it's better for you to keep it this way, separated, not combined like this. It will be easier for us to graph this one. So let's continue with the fourth restriction. There must be at least 3 new members, at least. So the new members, which is Y, at least 3. So 3 is the minimum value. You cannot take lesser than 3. So it cannot be 2, 1, or 0. But 3 can be accepted, 4, and so on. And then the fifth requirements or restrictions is the number of new member, Y, must be at least half of the number of old members. So this is the translation. And then less than, so the new members, Y again, less than, so there will be no equal sign, 3 times the number of old members, 3 times X. So keep in mind that if we use less than, so it's just less than the inequality sign. So again, I will remind you that sometimes you can combine these two statements into this long one statement. So it's the same. But let me just remind you again, keep it separated so you can easily graph it. So let's graph it. I will put it into this Cartesian, all of these restrictions. So this is it, the graph. Okay, I have already tried to graph it, and let's just try to sheet it then. Okay, let me just put this, and then let's go to the first one. The first one is x greater than equals to 0 and y greater than equals to 0. So actually, this is the x. Sorry. Yeah. So this is the first one. X is greater and then y is greater. So it's positive, right? So let's go to the second one. X is less than and equals to 9. It means this is the line. X equals to 9. Less than equals to 9, it means it goes left. Okay, and then y is less than equals to 8. So this is y equals 8. And less than equals to 8, it means it goes down. Okay, and then the next one is x plus y is greater equals to 6. Now the line is this, x plus y equals to 6. So it is greater than, it means above. And then x plus y is less than equals to 15. The line itself is this one, x plus y equals to 15. So less than equals to, it means it goes down. And then y is greater than equals to 3. So y equals to 3, this red line, since it is greater than, it means it is above. You shade above, right? And next, y is greater than equals to half x. So let's start to draw the line y equals half x. Y equals half x means the y-intercept is 0 and the slope is half. So let's begin with 0, and then the slope is 1 rise and 2 run. 1 rise and 2 run, and then just connect it. Okay, so because it is greater than and equals to, so it will be above. And then the last one is y less than 3x. So let's draw y equals 3x. So the y-intercept is 0 and the slope is 3. 1, 2, 3 rise, 1 run. So this is the line. Don't forget it is dotted line since it is less than only. And then you shade below. Therefore, if you see all of the directions of the arrow heads converge in this area. Let me shade it for you. Okay, and this is the visible region. As you can see, the green shaded area, this is the visible region. So all pairs inside of this will satisfy all of these restrictions. And all pairs outside the visible region must violate at least one of these restrictions. Okay, so since we are speaking about old members or new members, we're speaking about people here. So people must be integers, right? We can accept half of a person. So therefore, inside this visible area or region, I want to be clear that I will show all the integers pairs inside the visible area. It means there are total 1, 2, 3, 4. So 38 of pairs of integers. For example, 4, 3. So 4 old members and 3 new members is acceptable, is satisfying this restriction. And there are 38 of pairs that is acceptable since they are satisfying this restriction. So the thing is, we are trying to find from all of these 38 pairs which one that will give us the maximum total dollars earned. So we are speaking about the perspective of optimum point in this time is the maximum one. Since we are speaking about the money we earn, of course we want to get it as high as possible, right? So the optimum point in this case is the maximum. So which one of these pairs that will give us the total money, the highest possible money that we can earn? So let's go to the function of total dollars that we earn. So based on the case, the new member get paid lesser than the old member. So the old member got $10, and for new member they got $8. So the total dollars the club earn is the number of old members that that will be working times $10 plus the total numbers of a new member multiplied by $8, right? So this is the testing equation. It means we want to find which pair from these 38 pairs that if we put into this function or equation will give the highest value of dollars, the optimum one, since we are finding the maximum. So actually, conventionally, you can just try one by one. For this one, for example, this is 4,3. So 4 old members and 3 new members, 5 old members and 3 new members, and so on. And for this one is 7 new member, 7 old member and 8 new members. You can try one by one and then find out which one will give you the highest value, and that's the answer. But again, it is wasting time. So let's just I will show you how to use the first method, the testing line. So I will put any values of D that will give a representative of the testing line. But make sure, since you have to graph this testing line, make a value that is divisible by 10 and 8, so you can easily graph it. For example, I put 80. So if I use $80 that I earn, so I use the x-intercept and y-intercept technique. So the x-intercept is 8. This is the x-intercept. And the y-intercept is 10. So 10. Let me graph the testing line. So this is the testing line. This is 10, this is 8. So this is a line of $80 earned. So when you want to earn $80, so you need to pick any pair on that line that certainly give you $80. So therefore, you can conclude that all area below this line, all the pairs here will give you lesser than $80. And all the pairs above this line will give you more than $80. Since we're aiming to get the highest possible value, it means you cannot get from this part of area, right? So you are aiming from this area. There is a pair that will give you the highest value. Which one? So yeah, instead of try to draw another line, so let's just use this line, okay, as the testing line, and then we slide it. We slide it to the right since we are aiming to get the highest, and look for the last pair it touch. The last pair it touch inside the, okay, this one. Look, this one. This is the last pair it touch. Don't forget, you cannot change the slope. So slide it carefully. Okay, again, slide it carefully, and then, yeah, this one is the last one. So actually, I can be certain without comparing to any other pairs that this is the pair that will give me the highest value of dollars that I can earn. So it is 9 old members and 6 new members. So by having the optimum pair is 9,6, I put it into the equation D equals 10x plus 8y, this one. So I will find that this is the maximum dollars that I can earn by putting 9 old members and 6 new members to work. And I can be certain, without comparing with the other pairs, I can be certain this is the highest possible dollars that I can earn. So it will be greater than this one, this one, this one, this one. You can check. But again, since I'm using the testing line and I'm using carefully, therefore I can be certain that this is the optimum point. So if I change the objective, if somehow I want to find which pair from this that will give me the least possible dollars that I can earn, so with the same testing line, I don't slide it to the right, of course, I'm aiming to the area on the left, right? So let's just slide it carefully and then find where is the last pair that it touch. So actually this one, right? This one, 2,4. So 2 old members and 4 new members is a pair that will give you the least possible dollars that you can earn. I can be certain it's not this one, it's not this one, I can be certain this one. You can compare with 3,3, but I can be certain that 2,4 is the pair that will give you the least possible dollar. Then I want to explain you to how to answer I. Okay, 3I. So the situation is changed. How about if we change the policy that for old member they earn $10 per old member, and for each new member they earn $12. What happens? So which of this pair will give us the highest possible dollar that we can earn? So we have to change the testing line. Since the function itself is changed, so we have different testing line. So let us assume, let's put one value of the d that is divisible by this and this. I choose 120. Therefore, I can use the x-intercept will be 12 and the y-intercept will be 10. 12 and 10. So this is the new testing line. Right? This is the new testing line. So how to find which pair will give us the highest possible dollar? Let me slide it to the right. Which one is the pair that it touched last? So actually, if you slide it carefully, I can see that this one is the one that touched last. So let me just slide it again carefully here. Right? Yeah, this one is the last one. So the answer is changed. Since if we change the function of the dollars, so 7,8 will be the pair that will give us the highest possible value. So 7,8 is the optimum one. So the d will be equals to 7 times 10 plus 8 times 12. It is equals 70 plus 96. So it is $166. So that's how you find the optimum value. Okay, so if I change the policy, how if I want to find the minimum, the pair which give me the least possible dollars, it touched the last of this one. Yeah, so this one is the last pair it touched inside the visible region. So 3,3 is the pair that will give us the least possible dollar if we use this new function. So that's how you use the testing line and how we deal with integers. I hope it helps.